And without further ado, I would like to move on to tonight's topic, which is ML engineering panel discussion. We have 1 hour booked. Both speakers and panelists are very busy, so let's try to to make sure that we can complete this session within about 50 to 55 minutes. We will have I think enough time at the end to do Q&A. There are about 7 to 8 prepared questions. And let's get started. First of all, I would like to introduce, Indrani Gorti, who's currently the Director of Platform and ML Engineering at Loblaw Digital. And the second speaker is Yi, who's currently the Staff Applied Scientist, specializing in natural language processing, currently working for Five9. So yeah, I would love to hear from, both experts regarding the machine learning engineering career. And if you guys have any questions, feel free to send your questions to Zoom chat. We're happy to answer your question either along the way or at the end during the Q&A session. So let's get started. First of all, this question is for both of you. How would you describe your data science machine learning career journey so far? Who would like to go first?
You want to go first?
I see you already unmuted, so maybe first.
Okay, so my career journey in data science and ML has actually it's like a full circle now. I keep saying this. I actually started my when I did my master's, I did with a specialization in databases and semantic web. Then I actually started ever since my first job, I've always been lucky to be in the data industry, the data field. And in the industry, all my jobs have been within the data field. So I actually started off being actually pure data scientist. I did a lot of like Python programming, worked on logs for an AI company, a conversational AI company. It's called Nuance Communications. It's based, they do speech to text. And back when I actually graduated, that was actually one of the leading AI companies. So I was happy to work there. God gave me a lot of like industry experience on how, especially in NLP. But the thing was, although I worked for an NLP and speech-based, speech to text-based, company, I did a lot of my work actually doing like data engineering work for them, basically looking at the logs and then tying back the like what kind of insights I derived in order to improve the conversation AI system. So that's where I kind of did, but I also did a bit of like pure data science there as I learned. So one thing very early on I realized is both ML, like today we talk about ML engineering, but really I kind of really saw that having both skill sets is the way to go to kind of advance my journey. And since then, I've taken all kinds of roles in all kinds of industries like telecom, finance, fintech, startup, and also now retail and e-commerce. So that's basically what my journey is all about. I've done a lot of like pure data science. I've done like fraud, like I've done models to kind of detect different kinds of fraud use cases, to actually putting models in production, to actually doing like data engineering to kind of process data and munch the data. So that's why I call it a full circle for me. But anyway, that's about me. So I'll stop and pass it on to you.
Yeah, great. Thanks. I mean, that's a very exciting journey for you. I'm Yi. So I finished my PhD in 2019. Over the university, I was learning, doing a lot of research on the fundamental of deep learning for the embedding very specifically. So after my PhD, I joined a startup company called Almatics. It's doing a kind of a deep learning NLP-driven system to do a lot of question answering on the specific documents. So I was the second employee of the company and all the way down to the head of engineer over there. So it was an exciting journey. So I was overseeing the product from A to Z, all the way from POC of the idea down to talking with clients and solving the very specific needs to the clients. Then after that, I left and joined the ServiceNow. Over there, I was the what we call the ARS, Applied Research Scientist. So we've been giving a lot of different tasks to basically POC a lot of different new ideas try to solve some open problems over there. Then I recently just joined the 5.9. So I'm now basically the lead of the new founded NLP team. So our team is actually very small in nature. We only have 3 people in there. It's more like a startup in a big company. So every day is like we need to sync with 4 different teams that give us tasks, and all of tasks are just some raw ideas. So can we do ABC? And we just go over there and looking at the papers, what's the model available, then POC on those tasks. So yeah, it's a very interesting journey for me. So yeah, that's about me.
Thank you for the self-introduction. You both have a really amazing background, and I think Yi has been specialized in NLP, and Indrani in the last few years, I think she's been leading ML in production and deployment, and also scaling of the infrastructure. So today my questions are, I'll tailor my questions to you guys, and there will be some fun questions. Let's move on to the next one. This is still for both of you. Can you describe what a typical workday in your current role looks like?
So typically my day is actually attending to a lot of data requests, and also like model, like basically requirements for model serving and model management. Right now, again, my role has changed a lot since the last year, but typically my workday is all about actually catering to model lifecycle management, and starting from data ingestion. When I say data ingestion for the model itself, for models. So it actually also involves like lots of brainstorming with the ML engineers, as well as like business teams, to see what exactly they need, how they need, and what problem they're trying to solve. And typically, so since I kind of own most of the data platform initiatives, we do have like a platform and some capabilities. So we're always challenging what new framework should we bring, what new capabilities should we bring to the platform, in order to make sure that all our ML engineering needs are satisfied. So for example, for serving, model serving, do we have capabilities for feature store, right? That could be one thing. The second thing is, okay, now I understand certain problems, certain business problem, and where a model is required, and now we realize, okay, this is a problem where the model is going to have a lot of drift over time, and do I need model drift management for this kind of a problem, right? So then my role has a bit of both, coming up with basically applying software engineering principles for machine learning, as well as like understanding what kind of a problem are we solving, and how do you apply the machine learning solution to it. So it's a combination of both. But again, since we actually have to enable machine learning engineers, in a lot of cases, there's also a lot of innovation that happens in terms on the side. There's always some innovation that's happening, in the sense that bringing in new capabilities and things like that, which can be used for different business problems in the future. So that requires lots of like data, like scouting for the right data, trying to figure out data. Again, is definitely something that you can't avoid. It's always a problem in a big organization. So trying to get the data, trying to make sure that we have the right frequency of the data coming in, making sure that that is sufficient. Lots of A/B testing after the model is done. Also, we have multiple versions of models, so obviously there has to be A/B testing. So that's how, and also like once the model goes live, how like the model will always go stale at some point. So trying to make sure that we're actually managing that operations part of the model is what I do typically these days. Again, has been evolving quite a bit in the last couple of years. All right.
Right. I think I'll go next. So yeah, I think my experience is kind of similar to what we have here. So maybe I should maybe talk issues of individual contributor view. So I'm not still in the onboarding process for the 5.9, so there's not a lot we can talk over there. So like every day, just daily stand up, you sync with other teams, you sync with the team members, and see what they are working on and what you should be focusing on in the next few days or so. And then I will have like a 5 hours or 3 to 5 hours focusing time to working on your own problems, something like that. Then we will also have like the weekly brainstorm, ideation, and some of the reading learning sessions and the monthly knowledge sharing sessions. So those are the things are necessary for, I think, for all the machine learning engineers to know what's happening outside there besides your work. And because right now I'm still in the onboarding process, so maybe I should talk with my previous experience. So over there, I was the individual contributor. So my major duty is to POC a lot of ideas. So you have the PM, and PM talk with the clients. Clients will have a very specific need, say, hey, why don't we have a feature ABC? Then we break the feature down from the brainstorm, say that's option 1, 2, 3, and each of the hours of the researchers they will take one of the tasks and go over there and say, hey, does it work or not? If it works, what's the cost and what's the effort we need to make for that? Then we sat down, hey, we want to go with this approach very seriously. Then we say, hey, we want to do some engineering effort for that. So there will be a lot of code involving, and we need to write code and maintain the production code. And sometimes you also need to do the peer reviewing of your PRs and debugging for the clients. So that's, I think, more of the life of the individual contributor, if you ask.
All right, thank you. Well, let's move on to the next question. This question is for Indrani. What do you think are some of the latest trends in ML ops?
Yeah, it's an interesting question. I think lots of trends in recent times in ML ops, and you'll not know so many trends if not for if you end up using one of a tool that's available out there. But again, I think ML ops is just a combination of different kinds of techniques used to solve different problems within the model lifecycle. So basically, ML ops, as the name suggests, is operationalizing ML. And as you know, as you probably know, that whenever you build a model, you're building the model is always never going to work out for everything, right? You're always going to build a model with a few assumptions. But in real life, like, scale is definitely a problem. The first and foremost problem is scale. I mean, a very rudimentary way of saying it is that, okay, you build a model with some data, obviously, it's not the complete picture of the data that exists. So there's lots of unknowns. So when you try to productionize it, or quote unquote put it in production, and you throw real data at it, like, scale can definitely be an issue. Sorry, I'm just having a throat infection. Okay. And the other problem that I'm seeing a lot is like drift. Not just drift when the model results, but also data drift. Again, the same thing that I was talking about. Data could be different. You basically model your data in a certain way, but the actual data is also probably the right kind of data, but over the period of time, there is a drift, and you probably don't know that your model is actually not the right kind of model it has to be. So how do you the way you need to treat it in a model lifecycle is that at some point you need to retrain it. So how do you automatically know that this model is not good enough or fit enough, and you need to retrain it, right? Again, the answer is not automated training is not the answer for everything, because there has to be a human intervention. When does a human intervene there and say, well, we are going to be training it, as opposed to doing something, automatically. Again, it greatly depends on the industry you're in. So, you could do that in, like, say, retail or e-commerce. Very honestly, like, there's always a chance that you're retraining the model. But say in finance or fintech, you can't do that, because every model out there affects a lot of decisions, and it's reaching out to. I mean, you for example, a model which determines whether the rate has to change. It's not like some data scientists can change and retrain the model. It has to go through a very big model vetting process, right? So it again differs over a period of time. So drift detection scale is a problem. The other problem that I see a lot, the trend is basically trying to, keep up with really like an increased number of libraries and packages. That's become a thing, because these days MLOps is such a industry trend that there's a lot of like tools that are coming out of research. So really trying to see if that actually meets your necessities is definitely one thing. Again, putting the change management into MLOps is one thing. Drift detection is one thing. Experiment tracking, and also just basically being able to track every single thing that you run out there is one thing. A/B testing is another one, a very big one, where you're basically trying to route traffic to various models and determining which is performing well. And of course, what is a model performing well? It's basically you're optimizing for something. So once you know what you're optimizing for, how do you basically route traffic, do A/B testing between multiple models, and come up with a conclusion that one particular model works well? So these are all the things that happen in model management. If you think everything pre-deployment is one story, everything post-deployment is a whole set of like new problems that generally are there. And I think the post-deployment ones are actually is actually the trend now, because last year or so a lot of people have figured out ways and techniques and tools to kind of put models into production, or at least APIs and that kind of stuff. But post-model deployment is probably the new trend in MLOps.
Thanks, Indrani. I actually have a follow-up question. So, it's so like when you're learning MLOps, it's very painful process, because I think this MLOps world is heading towards many different directions. There are so many different tools in the ecosystem. Do you see like one platform that rules it all? Like ML Kubeflow on Kubernetes, or do you see companies actually still going to try different open source projects and stitch them together? I guess there's no right or wrong answer. It depends on the company as well. But I would like to hear your take on this.
Yeah, I think generally what will end up happening is people will either get used to completely a framework that can provide all of these capabilities, typically more or less most of the capabilities, or people will go for something very custom with people who are completely embracing the open source will start using certain tools for certain things. But the problem with them, the current tools and technology, is that there are so many tools out there that are doing things with overlapping capabilities. So, and that's exactly the challenge I was describing. It's very hard unless you actually understand this and actually sit and do, and then determine, even with two tools that are exactly doing the same thing, it's very hard to determine which one you want to pick. And then there is costing aspect to it. Then there is like, oh, should I pay for a license, or should I just go have more people do? Because signing up for a tool always comes with the fact that you're going to pay money. You're making a bit of a choice because you can't afford to hire a lot of people now. But there's also a lock-in problem you have, because the industry is so growing. I think a lot of like leaders are actually scared to put money into one framework, because God knows tomorrow another framework will come. And that's exactly why I think I like this course, because we actually teach the basics, and we are talking about, say, Kubeflow, right? Kubeflow is used comes in many flavors as different managed services on the cloud, be it many clouds. Like I'm not talking about AWS or Azure or Google. So if you know Kubeflow, I think you can do a lot of different things that come with the same open source package that's a different tool or a managed service. For example, A/B testing. If you can do one A/B testing, doesn't matter whether you want to do it in, like, I don't know, Vertex AI on Google or AWS SageMaker, right? So I think we should really concentrate on the basics. And I think once you know the open source versions of it, you can adapt anywhere. That's how I get, again, that's for adoption. But I see a combination of both. I feel like what will end up happening is every cloud provider will have their own framework, and then people will take that mainly and adapt with more open source for some add-on capabilities. That's where I see it going.
Thanks for your insight. Yeah, I definitely see, for example, I use AWS more. So SageMaker is definitely growing pretty rapidly.
Yeah.
But I also see like, these smaller ML startups, right?
Oh.
Start to challenge the big players. Recently I talked to some companies that just specialize in very one aspects of ML ops. For example, they can do model deployment really, really well.
Yeah.
And but they can do it at much lower cost if you want to retrain your models on deploy the models on GPU, right? But I totally agree with you, like, because these tools have overlapping features.
Yeah.
That's going to be a challenge. So I think there will be like a lot of merge and acquisitions in the future as well.
Yeah. So one thing, so this year and last year, there is a big MLOps conference that happens in Toronto. And I think the whole conference was flooded with, you know, tools and like, companies that are just solely focusing on observability. I think observability seemed to have been the trend. Like I could name like 8 or 10 companies doing exactly the same thing, all on observability. Now it really determined, like, that's unfortunately where we are. It's so hard to make a choice, like even if you want to go, buy one, right?
Yeah. And I think with the recent tech, job cuts, we're probably going to see more tech startups rising because, all of these top talents are probably going to have some great ideas and start some new companies based on AI. I have a friend who works for Twitter. Unfortunately, he got laid off, but now he's like starting his startup doing doing chat GPT kind of large language model.
I think I know who you're talking about, Rex, right?
Yeah. Oh, not Rex. The other friend of mine. He might actually join the next panel discussion to talk about his experience, but that's very interesting. I was talking with him last night.
Nice.
Okay. Well, next question is for Yi. Tell us your thought about ChatGPT, which is, such a buzzword in the past few months. And do you think it's going to replace MLE and data science jobs soon?
Well, the short answer is no. So ChatGPT is like this crazily popular right now. So, but at the end of the day, it's still just an NLP model, right? So, and what is NLP? So NLP is all about the context and the probabilities. So ChatGPT, I see that as a conditional language model, which is you give some condition, that's condition of context, then generate some language tokens to maximize the probability of the language model, right? So it's still like very general language model itself. The benefit for the great thing for the ChatGPT is like it have 175 billion parameters, which is like very huge model. It's over 800 gigabytes. So that's not some model, any company can run, right? So a lot of people just call the API, blah, blah, blah. Then this data, because they have a giant size of the parameters, so they have been pre-trained on a very large collection of text, few billion, few even training tokens of text. So the information and the knowledge, they have been encoded into the model and will be decoded based on the conditions context. So it sounds very amazing tool, right? You can do a lot of different things on that. But the problem is like, what's the accuracy? So for the language model, sometimes it's very hard to measure, right? So I can ask question, hey, what's a good restaurant in Toronto? The ChatGPT can give you like 10 different lists, and every single generation they'll give you a new list. But where is the ground truth, right? So it's more like the search engine, right? You type in some kind of query. Sometimes it just don't have ground truth. People just go there and browsing and say, hey, this is the information maybe I've never seen, I'm just interested. And another definition over there is like it's limited to 4,000 tokens only. So even though it allows you to put unlimited context over there, it only takes the latest 4,000 tokens. So those limitations also, it's something very restricted, right? So you can only apply that to a very simple problem, not saying programming some very complex system. It's not even possible. Then another limitation is like it's limited to the pre-trained knowledge. So the ChatGPT claim that they only support the knowledge up to 2021. So whatever happens latest, it won't know, right? And the other thing is like it's very hard to fine tune. Just like we said, it's 800 gigabytes. I mean, who is gonna fine tune that? So every fine tune may take a few $1 million. So I mean, if you want to ask questions, so how we can replace this stuff with with MLE, with a data scientist. I would say nearly impossible because MLE is very different, right? So engineers need to deal with a more complex tasks, a more complex content, and more complex requirements. So even though you want to fulfill all of your requests into compress them, so it's very likely to exceed it to 4,000 tokens already. So the ChatGPT will not respond. But if you say other fields, let's say very simple use case with some fixed or repeatable task, saying I got a friend, so he's working on a car dealership. I recommend ChatGPT to him, so he's now using ChatGPT to reply to email every day, and it's awesome. It's just awesome. And so his manager said, "Hey, how your English improved so fast in one day? I mean, it's ChatGPT."
That's funny.
So it's a real story. So the guy is trying to pay for the ChatGPT to do the job for him, and I just used GPT today to reply the message from my Airbnb guest. So it's amazing. It's amazing too. As long as you set the condition is like very limited and very restricted, like the simple task, it's doing a great job. But I mean, machine learning engineer and data scientists, they are never simple, right? So they evolve every day. Just like we said, we have 10 different startups, I mean, since 2022, right? So ChatGPT don't have that information, then it won't gonna be replaced as soon.
Mhm.
Okay, thanks. Yeah, I read a blog post, right? Someone is using ChatGPT to generate some machine learning model training code. I think it's just a couple of lines of scikit-learn code, train test split, right? Model.fit, and then .predict. But I think that's not the real value of a data scientist, right? So that is something that should probably be automated, and it's just a Google search away. Like you can find it anywhere. So yeah, so I don't think a real data scientist will be replaced that easily, because just writing the ML code itself is probably not the real value of a data scientist, because you still need to focus on the analytics side, and also the data is always messy and different for different companies and different use cases.
Yeah,
Cool.
exactly.
Next question for Indrani. What does it take to become a professional in the machine learning engineering field? Can you give us some inspiration on the kind of education courses, the tools we need to learn, the skill sets we need to build?
Okay, what does it take? A lot of hard work. So it's a very interesting field. It's actually a combination of like software engineering, machine learning, as well as data engineering. So if you're not either of them, then it's a lot of hard work, and lots of tools. But if you know one of them at least that you're close to, it's still going to be work. So it's actually a new field. So lots of work. I'd say actually, education is, when I say education, I think rather than saying it is education, I would rather say a very systematic and like a disciplined way of lead. If you really want to like start, learning it, you got to be very disciplined, because there's lots of tools and lots of capabilities that you need to learn. And it's you're never going to unleash the value of ML, machine learning engineering, unless you do an end-to-end problem. So I think that's well, then you will ask me whether you have to do all kinds of courses: data engineering, machine learning engineering, and data science. The answer is yes and no. I mean, it's nice if you know all of them, but to begin with, I think you should know bits and pieces of everything, just the enough pieces to kind of get you going in productionizing a model, and just deploying a model kind of thing. And then you can actually, depending on what your interest lies, you can actually go towards that area. For example, the software engineering aspect of it, you should know some basic CI/CD, basic programming, like maybe in Python or so, and then understanding, traditionally, like, how traditional microservices work, APIs and that type of thing. From data science, I think data science or ML, I think you should really know what is exactly a model. Like, even if you're not like a pure, researcher in ML, you still can aim for an ML engineering role if you know that, typically a model is what happens in building a model. What are all the steps that involve in making a model? How do you actually, how does it actually model look like after the data scientist has done many iterations and experimented and came and gave you the model? How do you actually manage versions of different models? Those type of things coming from the data science portion. And the data engineering portion, I guess, like all the steps leading up to actually taking the data and stitching that whole cycle from getting the data ingestion, putting it into some place where you can actually serve the models from, and all the way till actually calling that model all in one big pipeline or so. That's the data engineering aspect of it. So I think you should know at least these from these three fields, and then it's up to you on where you want to expand once you are really doing it. So something like a capstone project in the end would really be good if you are learning it in terms of like when you say education or skills. But skills generally start off with these. I think the rest will come automatically to you the more you actually do real world problems and deal with like case studies and that type of thing. Yeah. By the way, the WeCloudData ML engineering program is really great. I've been very close to it for the last year or so. So I think it covers everything that I just told. So I'm also kind of biased. It's a very nice course.
Thanks, Indrani. We also see some questions coming in. So if you have any questions, feel free to leave that in the meeting chat, and we will get to those questions at the end. Okay. All right. I think we have only two more questions left. Any advice for those who would like to get more specialized in natural language processing?
Yeah, so I mean, the whole NLP field grows very fast recently. So if you look back, 2013, we have Workday that opened like new chapter in NLP. And to 2017, we have Transformer and BERT. And just from last year, beginning of last year, the generative model, something like GPT-3 and T5, they got popular. So it's like very young, right? So since it's very young, so you need a lot of good attitude to learn, to acquire those kind of new knowledge, to know what's different between those models and to know the specific use case for that. And to catch up with latest technology, you must know the very basic machine learning and deep learning concept, right? So you need to know the fundamental of the NLPs, all the way from the traditional methods, saying bag of words, and the TF-IDF, BM25, search engine, those kind of stuff, all the way down to sequence, LSTM, RNN, CNN, and then transformer, encoder, decoder, those kind of stuff. So it do have a learning curve, but in the WeCloudData, we also have course to cover all those concepts. So it's very similar to the traditional machine learning. It just needs a little bit different tricks over there because the data in nature is kind of different. So once you know the difference, we'll know the relationship between the NLP with traditional method, with traditional deep learning, machine learning kind of approach, you can catch up with latest concept very easily. So, but if you want to specialize in NLP, for the modern NLP, I would say, you need to learn the transformers. You may need to go with some on-hands projects. So right now, there's a lot of companies that provide you like APIs to call, right? It sounds very easy, but if you don't know the fundamental, you don't know how it works in nature or environment, then it's very hard to, tune those models. It's very hard to achieve a successful rate for those models. So yeah, there are many details here, but it just takes some time to learn. The good news is that the NLP like the rising star for the whole machine learning career. Every single company, they are trying to leverage GPT-3 or ChatGPT, those things into their product. And the trend is dancing there. And I'm lucky enough to step into the right small field. But I mean, yeah, that's it.
All right, thanks, Yi. You know what? Because we have a hard stop at in 20 minutes, and I start to see more questions come in. I think some of the questions later, tips on interviews, are actually quite related to the questions that got asked on the in the Zoom chat right now. So let's just get to those questions. So the first private question I got was related to how to get in, right? So how do we make a career, shift to ML engineering? There was also a related question down below, which is about how to switch from data science to ML engineering. Who would like to take this question?
Unfortunately, since I can take it up. So unfortunately, since I don't have one answer to this, because ML engineering is generally a new field. So it's a good thing and a bad thing. It's a good thing because, if you really want to get into it and you put in the hard work, you can get into it before it becomes the traditional route for it become more established. However, no, I understand the concern behind, why anybody is asking this question. So I think even with ML engineering, it's really depends on what kind of a team. And I'm sure that today ML engineering team, including mine, you'll find people who are a little more good on software engineering than people who are into really applied science, right? So you should really think about at least having some niche for yourself, and say if you're really good with applied science, and you've done a lot of research, you've applied quantitative methods in the past. I mean, I think that's, you should really say, okay, I'm going to learn a few things like putting a model into production, deploying it, and I think where you need to focus on is actually making sure that your actual skill is actually shown out. I also see people with no ML experience at all, but people who are really great software engineers. They understand CI/CD very well. They understand like all that kind of stuff very well. But for them, it's like, okay, it's just another endpoint. Sure, it's a model, but those things you can always learn. So I think you should really concentrate on more of your skills that you have, and go towards actually the field. But don't get afraid, because really, I'm being very honest. And all these teams, I don't see anybody who's and there is obviously no way anybody can master the entire the ML space, because it's growing a lot, right? When I went to school, like, if this was one course. Today we have an entire, like, a master's on data science, a master's on whatever, right? So it's not like master's in computer science anymore, master's in statistics anymore. I'm just telling this to actually, like, I know it's hilarious, but I'm really telling you that this is a reality, right? You find people from all kinds of fields. It's only you who can change it. The more you do, the more you learn, and the more you have, like, you should be able to advertise yourself. Of course, that is always there, but yeah, concentrate on things that matter, based on what your skill set is. Currently, everybody is different. So if you know some NLP, hey, take an NLP model, do with something with it, right? Show that as something that is a skill set. If you've done some kind of, like, I don't know, you've dealt with a problem of scale in the past, apply it to machine learning API or an endpoint, and take it from there, right? So always go, don't ever think that you're not good enough. Just keep working towards it, and I think you'll get it.
Thanks, Indrani. There are two more questions for you. One is about the switch between data science and MLE. Another question is, what is your go-to resource to be updated with ML ops field and industry updates? If someone has taken, let's say, Andrew N's ML in production course on Coursera, any other recommended learning path apart from that?
That's a good learning course. But very bluntly speaking, I think the best source today is actually going to Amazon or Google Cloud documentation, and looking at their managed services, and seeing what is new and actually trying them out, because they're so up to date. Also keep seeing what is coming up in beta to see within that space, to see what is the trend. Honestly, I think that should give you a better idea, more than like a course. A course is good to kind of learn, with it gives you some discipline in terms of learning. But if you really want to know trend, I mean, go to SageMaker's page, go down. I mean, you go to AWS, there is actually an entire section on ML ops. at least that'll give you an idea, okay, what is this all about? Like, what is the hype all about? And then you can dig deeper and say, okay, for this particular problem, observability problem, or for experimentation tracking, you can Google and see what are all the tools there, and then try out 1 or 2 open source tools, right? You can try out MLflow, you can try out Kubeflow. Both of them achieve some parts the same thing, right? But then the more you actually do these things, you'll also realize that, hey, I can't run this unless I know Kubernetes. And then you will go down this rabbit hole of learning Kubernetes. So not to discourage, but I think the trends, I think the best place to go is AWS blogs. But if you want to learn something, again, go the traditional route. The course is really good. Our course is really good. But trends is really honestly like keeping up with blog posts, Medium articles, AWS documentation pages. Also, like some of the really good companies, like big companies who are really good with ML, like they technically they always maintain, typically a good blog, an engineering blog for you to learn. So don't get too hung up on the ML part of thing. Just look at engineering blogs and see what they did. Even if it's a learning that came from a particular use case, it'll get you thinking about the actual machine learning problem behind it. Yeah, that's my 2 cents here. And that's why it's actually important to know a little bit of engineering as well. And coming to the next question, I think data science to machine learning, I see this a lot of a problem, even in my current role and in my previous companies. People who are very excellent people for PhDs, people who have done really good work often have this. So you should get beyond your notebook, Jupyter notebook, and see what comes later. I think that is the main thing. And I see Yi nodding his head. So, like he mentioned, keeping up with all these trends, but still, like it only comes to a value if you can actually make it work to solve your business problem, and that requires some engineering skills. So go beyond your beyond the notebook, learn new things, and be like the first and foremost step for pure data scientists is to learn a little more about infrastructure, um, you know, and that kind of thing, so that you'll get, you'll understand things like how do you orchestrate something, or how do you you know, some software engineering principles, CI/CD, DevOps. That's if you know those things, I think it's very easy to transition from pure data scientist. And honestly, if you master that, you are unbeatable because you have the best of both worlds, and your skills will be like you're gonna hotcakes. So that's how I see it.
Thanks, Indrani. The next few questions are for Yi. How do you stay up to date with the latest developments in NLP and cloud technology?
Yeah, so for that part, I think still till now, the whole NLP, the leading NLP researchers, they are a very small group. So if you want to follow up what's the latest, you can just follow up the Hugging Face. So every day there are a new model posted over there, and there are a few founders over there. They post the link time to time in LinkedIn. So there are only few people you need to follow, like the one from Cohere, the Adrian, Neil, the few guys from the European, the Hugging Face guys. So those are very good results you should follow. So most of the time they just release their model and make some announcement. So right now it's not paper driven anymore. So if you like 2-3 years ago, I would recommend say go subscribe keywords NLP in the Google Scholar. But now it's not needed anymore. Every day, just you have new model and people just talk about that. Yeah. If a model, people talking about model, there are definitely something in there and you should take a look. So, and again, on the layman, they are all the same. Even now, so the transformer is proposed in 2017, right? And now even for the ChatGPT, the GPT-3, or T5, different kind of models, they are still transformers. They're just transformers trained with different tricks on different corpus, on different tasks. So we have the technology over there. Now it's time to land that to production. So I think right now we don't have any new, very innovative kind of stuff coming up recently. But now it's about a lot of tools, how we use that, how we leverage those tools.
I was just going to add along the same lines. I think that's a very nice statement because be it NLP or computer vision, I think there's a lot of like these Hugging Face or like many GitHub repositories where you can start using ready-made models available as well. And I think to a large extent, the emphasis now on engineering is so high that to a large extent you're also getting pre-trained models even within your managed services in the cloud. So to really do like basic stuff, you really don't need a data, like you really don't need too much work. You can just use a model that's available. In fact, I'm also seeing a lot of trend where for these really large models that take days and many hours to train, people are also coming up with other ways, other monetization, other marketplaces, or even for that matter, blockchain based companies that are saying, hey, we have a model that we ran for like so many days, but if you want to do that, here's the reward. Same principle as a blockchain, and they're trying to monetize for it. So again, monetization can come in many ways: marketplace, that, this, GitHub, name it. But what does it really mean? It really means that there is a lot of models available. It's almost something that you need to concentrate on right now, is like tools and techniques and how to integrate them into your projects. Yeah, sorry, I took your
Thank you, Johnny. It's well said. So there's another question from Zach. What are the essential components of any ML job interview?
It's a hard one again. It depends on the team. So I'm thinking that if you go for an ML like a platform team, I think it'll be mostly around system design, software engineering principles. Typically, a take-home test with some kind of a problem, and not necessarily a really hard machine learning problem, but a problem where they'll try to see if you can solve for something simple, like coming up with some kind of recommendations, or coming up with some kind of like forecasting technique, or like any one of a typically popular machine learning model, and then coming up with an interview where you discuss these results from your take-home test. And then typically system design. System design is very important because that actually makes sure some software engineering principles in terms of how you design things, because you're not just concentrating on like low-level code and stuff like that. And then maybe another interview to talk about like fundamentals of ML and deeper questions around that. So that's how I think I've seen most interviews go. But again, depends on, job to job. A very specialized NLP job might be different. A very specialized computer vision job might be different. But I'm just talking for a general ML engineer, open to all kinds of backgrounds. I think this is how it goes, because they'll still need you to know basic ML and basic engineering.
Cool, thanks.
Yeah,
I'm just
and
trying
I
to
think I can add a few things here. So like for the general interview of the ML interview. So for the MLE, there are two major parts of duties, right? So first part is R, the other part is D. So for the R part, the researcher part, you need to know the fundamentals. And I've been seeing a lot of code interview recently. It's been raising the bar higher than before. So like 2-3 years ago, if you want to interview for a machine learning job, the interview just like a code interview, right? Very general code interview. Right now, people are trying to ask you to code some LSTM, to code the GPT. So I was interviewing the Cohere. They asked me to code the mini GPT all from scratch. So the bar becomes a little bit high, but as long as you know the fundamentals, you should be okay for that part. And the other part is for the D, the development. For the development, just like what Jenny said, there are a lot of system design involved. And the best way to tackle that interview is to show some real project. So there are some interview right now, they are kind of project focused. So if you say, hey, I've been done this project before, and that project aligns with the company's product, then they will ask every single details in the project. So if you truly did the project before, the project is already in production even, so that will be a very good portfolio in your resume. So I would say both part was offered by the WeCloudData. So we have the course to teaching the fundamentals. We have the on-hand experience of the projects, which will be a big part contribute to your resume.
Thanks, Yi. Just mindful of time. We have 5 minutes left, and I got some private questions. We'll make sure that we get back to you after this session, maybe through email. But there are 2 questions left. Let's get to them quickly. One is regarding AWS Solution Architect Associate. Will this certificate or whatever learning path regarding Solution Architect be helpful for landing MLOps job? And the other one is it easy for a new grad to get into ML engineering, fresh grad with bachelor's in computer science or data science? We'll start from the solution architect question. Is that relevant for MLOps?
AWS solution architect would not completely relevant, but can be useful for the software engineering aspect of it. But I wouldn't necessarily say the course itself would cover MLE kind of a job.
Yeah. For example, like in our curriculum, we do cover Amazon Web Services because the models will be deployed in AWS. So, I think we go through a couple of iterations. You'll start with a Docker containerized model deployment using fast API. Then we move on to like a deployment in the cloud, right? So you do need to be comfortable with EC2 storage like S3 and Lambda functions. How do we do that in a serverless fashion? So I think understanding, AWS is definitely going to be very helpful. That's just the infrastructure layer, right? But it's not, but most of the time, I think you'll be working with other tools which are based on, on the cloud. For example, if you run Docker, Docker is running on the AWS infrastructure, right? But you still need to be familiar with the containers and stuff.
Mm-hmm.
Another question is just, computer science, new grad, how hard is it for them to get into to MLE directly?
It depends. I think it really depends on the market. So right now the market is flooded with all these kind of laid off people, and the companies are trying to do the hire freeze. So I would say as a current market, it's a little bit hard, but in general, I would say it's very common. So every company has this headcount issue to the junior, senior, then to start level, and everyone needs to grow from the junior position to a senior one. So I won't say it's like impossible. It sometimes takes a little bit of luck, and sometimes depends on the market, and of course your resume, because if you cannot pass the resume round, so there's no interview at all, right?
Lovely.
All right, cool. I think that's it for today's session. Thanks everyone for joining this session. We're going to have some follow-up panel discussions. There will be different panelists as well. But today, I would like to thank our panelists, Indrani and Yi. They're both teaching with WeCloudData. Indrani is teaching the MLOps part of the curriculum, and Yi is teaching the NLP part. So if you guys are interested in exploring MLOps and ML engineering courses, you can go to WeCloudData website and find out about our courses. Thanks everyone for joining. I hope you guys have a great evening, and I'll see you guys in the future.